Okay, here's where things are going to come together just a little bit. So what we're going to start off with here is we're going to look at this problem, and I want to ask you, which of the other methods do we have that you could use to solve this problem? Well, we could do elimination technique or substitution technique, and the Q and the R here, instead of having actual values, we could work with those, right? But reduced for echelon form in the calculator is now kicked out because the calculator can't handle the Q and the R. So this is the prime example of when you want to use matrix inversion, because I like calculator, I like technology, it speeds me up. I don't want to do everything by hand. Now, some of you may be arguing this is easy enough, it's small enough, I don't mind doing it by hand. I agree. But if you had 30 variables, I don't want to do this by hand. I want technology to help me. So, or at least do as little of it as by hand as possible. So I can still break this out into ax equals b format. Pause the video, try to do it yourself. Okay, so if I'm going to rewrite this as ax equals b, this would be a 1, -4, 6, 2. There's my matrix A. My variable matrix would be x and y. Now my B matrix would be q and r. All right, so now the nice thing here is our technology, where the hardest part of this right for us is the inverse. And this doesn't have any interesting characters in it. It's still just ones, -4s. It's just values. So the calculator isn't hindered one bit because of this weird Q and R that it's being set equal to. So what we'll do here is we'll go into here. We're going to go into our matrix, and we're going to edit our A matrix and make it a 2 by 2. And we're going to type in a 1, -4, which I already had in there, 6. Oh, perfect. Look at that. How convenient. Okay, so now we got that. So what I'm going to do now is I'm going to go matrix, and I'm going to grab my inverse. Now, I can't do the B in my calculator. I can't do the whole thing in there because I can't deal with the Q and the R. I don't know what those are. But what I can do now is I now know A inverse is 1/13, 2/13, -3/13, and 1/26. So welcome to why I wanted you to learn how to do matrix multiplication by hand, because we know A inverse times B, whoops, excuse me, there's no line there, QR, that whole thing, A inverse times B, is equal to my variable matrix. So now I can solve this problem. I just have to do the multiplication by hand, but I can solve this problem. I can do my rows and my columns and get this answer. Now, some of you might be a little panicking at the moment, saying, "Oh, I don't like fractions. I'm a fraction phobic." Well, don't worry. It's super easy because it's rows by columns, right? So 1/13 times Q. So 1/13 Q, right? So the 1/13 times Q makes 1/13 Q. So then I go over, so it's 2/13 times R. So this is going to be plus 2/13 R, right? So then I'm done with, that's my row and my column. So I'm done with that one. So now for my bottom, for the bottom row, and it's just one column. So the bottom row would be, -3/13 times Q, plus 1/26 R. And you're done. That's your multiplication. We're finished. Do you get how easy it is? Even though there's fractions, it's not that scary. Not a big deal. Okay, now, singular matrix. What I want you to do is just to understand that not all matrices have an inverse. Whoops, didn't mean to go to that one. Not all inverses have a matrix. Not all matrices have an inverse. It would be like the equivalent of multiplying by 0. If you multiply by 0, 3 times 0 equals 0. How do you undo that? How do you get the 3 back? You can't. There's no inverse operator for multiplying by 0. And that's what a singular matrix means as well. That's why it's called singular. It doesn't have a pair. It doesn't have a partner. It's just by itself. And how we can verify that is if we go to here and we put this matrix in as a 3 by 3. I'm going to go ahead and pause the video so we can, you don't have to watch me type in all these numbers. There we are. So we have our matrix. So now what we can do here is if I were to go and put this matrix into here and ask it for its inverse, it'll tell you error. There's a singular matrix. So just know this would be like wiping out. There is no inverse. There's nothing you can do. You can undo. So you would just say it's singular. We're not going to run into that a lot in this class, but it's more just so you're aware that it exists and that what it means. And that's the equivalent of like no solutions. The problem has no solutions. If you were to do this, like if it came from a system of equations and you were trying to find the x-intercept or the where all the lines intersected, there would be no solution if it was singular. So nonetheless, that is our inverse matrices. So please write a summary, try the work, and I hope it all goes well.